Let's start solving this question on horizontal projectile motion. So here you see that this is a tower which is 24-meter long. From the top of the tower, an object has been projected horizontally. So this has been projected horizontally. Due to the gravity, the object eventually falls to the ground and hits the ground right here. So this is the path, the trajectory the object follows, what we call as a parabolic path. So while solving this question, say using two labeled arrows, show on the diagram above the direction of the velocity v and the acceleration a of the ball when it is at point P. So when we are going to label these two quantities at point P, the velocity is obviously acting along the tangent of this direction. So this is the velocity which has both the horizontal and vertical components. So this is now not required to show in the question, but if you just look at this, that this velocity does have one horizontal component which is same as here, the horizontal velocity with which it has been projected, and it has also the vertical component right here along this direction, because due to the gravity the object is vertically accelerating. So its vertical velocity will keep on increasing, and this vertical velocity is acting in this direction. So this is the vertical velocity, this is the horizontal velocity. So the resultant of these two velocities must be acting along the tangential direction of this trajectory, of this curved path. So this is V, how I located and how I drew with the arrow. And its acceleration, so it does not have any horizontal acceleration because the air resistance has been considered negligible. So it does not have any horizontal acceleration, it does have only the vertical acceleration. So this is the vertical acceleration A, which is nothing but the acceleration due to gravity. So this is V, this is A. We have got the answer of this question A. Now question B1, calculate the time taken when the ball is thrown to when it first hits the ground, assuming there's no air resistance. So right here, when it first hits the ground, what vertical height it travels? It travels a vertical height of 24 meters. With what velocity it has been projected? It has been projected with this velocity. The value is not known to us, but since it has been projected horizontally, it does not have any initial vertical component. So right here, the initial vertical component is 0. So the height it travels vertically is 24 meters. It did not have any initial vertical velocity. For B1, we are going to make use of this equation, that h equals to initial vertical velocity times t plus half gt square. And since it does not have any initial vertical velocity, so this term goes to 0. So h equals to half gt square. G is the acceleration due to gravity, which is acting vertically downward, which is why the object gains the vertical velocity as time goes on. So it does not have any vertical velocity the moment it is being thrown, because it has been thrown horizontally. And as we discussed earlier in our last video, that horizontal and vertical, they are completely independent to each other. The horizontal does not have any effect along the vertical does not have any effect on the horizontal. So perpendicular components are independent to each other, remember it. So if I subject t here, this is twice h over g, and under root of this, so we have the value of h, which is 24. We know the value of g, which is 9.81. So take the root of it, you will get the answer in seconds, obviously. Now B2, the ball hits the ground 27 meters from the base of the tower. So this distance has been given. Horizontal displacement 27 meters from the base of the tower. Calculate the speed at which the ball is thrown. So this has been asked to find out. So we know the horizontal velocity, we know that what time it took to hit the ground right here, and as we discussed earlier, the time right here, at this time the object covers this much vertical height and parallelly this much horizontal displacement. So this is the time which is same for the horizontal and vertical. So the time of flight is same for horizontal and vertical. At this time when it hits the ground, it simultaneously covers this much vertical height, 24 meter, because from the top of the tower it reaches to the ground, and it travels the horizontal displacement of 27 meter parallelly as well, because it has been projected with some horizontal velocity vh. So from the tower, base of the tower, this much the distance it travels horizontally. And since the horizontal velocity doesn't change because of no air resistance, so for B2 we are going to make use of one simple equation, which is horizontal displacement is equal to horizontal velocity times time. No acceleration, no deceleration. The ball does not experience any resultant force, so no deceleration. The ball does not slow down horizontally. The ball does not accelerate even, because the ball has been projected horizontally once, just the moment it is being thrown. So if I now just subject Vh, I am going to get the value of Vh here, because time has already been calculated. So if you just subject Vh, you are going to get the Vh value. X is 27 here, and time is right here, whatever you have got. So this is something in meter per second. So this is the first question on horizontal projection. So now let's look at question number 2. So here is question number 2. So see that the aeroplane shown in the diagram is traveling horizontally at 95 meter per second. It is traveling horizontally, remember. It has to drop a crate of emergency supplies. The air resistance acting on the crate may be neglected. So there is no air resistance acting on the crate once it is being dropped from the airplane. And this is the point at P from where the crate has been released. The crate is released from the aircraft at point P and lands at point Q. Sketch the path followed by the crate between P and Q as seen from the diagram. So between P and Q, because it had some horizontal velocity, so the crate, when being released from the crate, it will still have some horizontal velocity, and this is why it is going to follow this trajectory, and it is a parabolic path. So this is where the crate is likely to hit the ground. Sketch the path followed by the crate P and Q. Here it's done. Explain why the horizontal component of the crate's velocity remains constant while it is moving through the air. It has been indicated in the question that air resistance may be neglected on the crate. So although the aircraft is moving through the air, but crate does not experience any air resistance. As crate doesn't experience any resistance, the horizontal velocity is also not changing. It is not getting slowed down, not speeded up. So horizontal velocity remains same because there is no air resistance acting on the crate, as stated in the question itself. And this is what being always stated in doing some maths in the projectile chapter. Now B1, to avoid damage to the crate, the maximum vertical component of the crate's velocity on landing should be 32 meter per second. Show that the maximum height from which the crate can be dropped is approximately 52 meter. So its vertical velocity is 22 meter per second. This is right here. It is going to gain a vertical velocity of 32 meter per second. So its horizontal velocity is still same as 95 meter per second. It is going to remain the same as before because no air resistance acting on it. So 95 meter per second is going to be its horizontal velocity. The vertical velocity is 32, and for this vertical velocity 32 meter per second to gain, the crate should be released from a height of 52 meter. So since horizontal velocity doesn't change, so there is no acceleration or deceleration on the horizontal velocity, but due to the gravity the object is speeding up, and this is the maximum vertical velocity it reaches when it is going to hit the ground. So we have this maximum vertical velocity right here. It did have only the horizontal velocity. The vertical velocity was 0. The vertical velocity was 0. So right here it was 0. So we'll be making use of this equation, v square equals to u square plus twice as, and here the vertical velocity is 32 square, u is 0, 2 times a is 9.81, it is the gravitational acceleration due to the gravity, and s is the vertical height what we are going to find out. So now check it out, you are supposed to get something approximately 52 meter. Check it out. Number 2, calculate the time taken for the crate to reach the ground if the crate is dropped from a height of 52 meters. So it is as simple as that. We have already done it. The height h equals to half gt square, because the initial vertical velocity was 0. This initial vertical velocity was 0. The final vertical velocity is 32. So as the initial vertical velocity is 0, so it is just only half gt square. So calculate the time right here. H is already you found as 52 meter. So whatever you got right here in this question, you are not going to substitute this h value right here, because question particularly asked you for calculating the time taken for a height of 52 meter. Now r is a point, so calculate the horizontal distance qr. So you have to find out this qr. So for this you are making use of this equation. The horizontal displacement is basically due to the horizontal velocity times time, and this horizontal velocity is 95, which you have already calculated, and time is this time that you calculated earlier. So this is going to be your horizontal displacement in meter. Now C, in practice air resistance is not negligible. State and explain the effect this has on the maximum height from which the crate can be dropped. What it is going to be, think. At what height the object is now supposed to be dropped so that its vertical velocity does not exceed this 32 meter per second in practice, where air resistance is not negligible. So in practice, for 32 meter per second to reach, since the air resistance is still acting on the object, so object is not accelerating constantly at the rate of 9.81 meter per second. So the vertical height, maximum height, can be greater than 52. The maximum height can be greater than 52 meter. Why? Because if it is dropped from a height greater than 52 meter, because of the air resistance, the object is not going to gain as much the velocity as it gained earlier when there was no air resistance. So its vertical velocity will not be able to reach to 32 meter per second if it was dropped from 52 meter above the ground. If it was dropped at a height 52 meter above the ground, it is not going to reach 32 meter per second if there is any air resistance. So since the air resistance is there, 32 meter per second it can reach at the maximum level, the vertical velocity. So the maximum height can be greater than 52 meter. Think and let me know if you have any question. Thank you.